Our target for the lesson is for you to be able to say at the end of the lesson, I can use the discriminant to determine how many solutions a quadratic equation will have. So as a reminder, quadratic equations can have 2 solutions, 1 solution, or no solutions. Here is the definition of the discriminant. And please make sure you get this down. The discriminant is the expression, which means basically math without an equal sign. It's the expression under the radical in the quadratic formula that allows you to determine how many solutions you will have before solving it. I want you to think back to this problem right here. Notice that we got a negative under the square root, and that's a sign that we're going to have 2 imaginary solutions or no real solutions because it has that I in here. But remember back to when I had a positive number under the radical and I got 2 solutions, and those were real solutions. So we've already kind of been introduced to this, but we haven't really discussed it in depth, but we will now. All right, the discriminant is going to be that red portion right there. It does not include the square root, it just includes what is under the square root, or b squared minus 4ac. Here are the properties of a discriminant. If you get the discriminant is positive, then you know that there's 2 real solutions. Just like what I showed you with the square root of 36, or 36 is positive, so we know we're going to get 2 real solutions. All right, here's another one. What if we have 0? Well, we haven't seen that example yet, but I will tell you that when you get the discriminant is 0, you'll have 1 real solution. And that's because you'll be plus or minusing 0, and that won't give you 2 different solutions because adding and subtracting 0 doesn't change anything. If you don't know what I just said there, that's all right. Just memorize that if it equals 0, you've got 1 real solution. And the last one is if you have less than 0, if it's a negative number, then like we saw before, there's no real solutions, but there are 2 imaginary solutions. So let's go ahead and apply this and see what problems look like. So example 1 says find the number of solutions of the following. Well, the first step is going to be to set that equal to 0. So I'm going to subtract 1 from both sides. The 1 minus 1 cancels, and I am left with 0. I'm going to rewrite this as a 3x squared minus 5x minus 1. I can't combine the minus 1 with either of these 2 terms because they're different. One's an x squared, one's an x, and one's a number. So we can't combine any of those terms. They're unlike terms. All right, now we can identify that a is equal to 3, b is equal to -5, and c is equal to -1. And now let's go ahead and calculate the discriminant. That's b squared minus 4ac. Please remember your parentheses. So this is going to be parentheses -5 squared, because that's my b, minus 4 times parentheses a, and then c is -1. Please always get in the habit of putting parentheses when you substitute a value in. Well, I can do this in my calculator if I want, or I can do this out in my head, and I get 25, and -4 times 3 is a -12, times -1 is a +12. You know that's true because if a minus times a minus is positive. All right, so that's going to give me, what is that going to give me? 37? Okay, now that 37 is greater than 0. It's a positive number, so let's go back and see what that says. That's one of these cases right here. And so we would just answer with 2 real solutions. All right, so our answers would be 2 real solutions, meaning our graph would cross the x-axis twice. I guess I did this all out. Silly goose of me. I don't know. All right, let's try this one. Again, I'm going to subtract 2x and add 3. Subtract 2x and add 3. Disappear, 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 disappear equals 0. X squared minus 2x plus 3. All right, here we've got an a equals 1, a b equals -2, a c equals 3. So we're doing b squared minus 4ac, which hopefully you have memorized by now. So this gives me a negative 2 squared minus 4 times 1 times 3. So that's going to give me 4 minus 12, which gives me negative 8. Negative 8 is less than 0. So we're talking about a negative discriminant. Well, let's go back to what we had before. If I have a negative less than 0, we have no real solutions and 2 imaginary solutions. So that would be our answer for those. Get there in a second. So this would be no real solutions, 2 imaginary. Imaginary. 2 imaginary. So that's our answer. In other words, if we were to graph this, we would see it does not cross the x-axis. Oh, looks like I did it all out again. All right, last one, folks. So we're going to do 4x squared, and I bet you can do this in your head. Bring that to the other side, it becomes a minus 4x. Bring the minus 1 to the other side by adding it, and you get a plus 1, 0. So my a is equal to 4, my b is equal to negative 4, and my c is equal to 1. So this is going to be a b squared, or a negative 4 squared, minus 4a times c. Well, this is going to give me a 16 minus 16, which is a 0. And we know that 0 is one solution. And if you're confused about what this would look like, this would be a graph where you have something like that happening, where you're only crossing the x-axis once. All right, so just to quickly summarize this, you just need to label your a, b, and c, make sure your equation's set equal to 0, plug into b squared minus 4ac. If it's positive, it's 2 real solutions. If it's negative, it's no real solutions, but 2 imaginary solutions. If you get 0, like in this case, it is 1 solution. Thanks for watching. Have lots of peace.